The definition of the derivative, part 3. The definition of the derivative is the limit below. And here it is, of course. The limit as h heads to 0 of f of x plus h minus f of x over h. And again, if we plug 0 in for h, we're going to get 0 over 0 on indeterminate form. We get this every time we take a derivative using the definition. Example 1, use the definition of the derivative to find the derivative of f of x if f of x is the square root of x. Well, as usual, the most important part is the setup, and I'll move this up a little farther here and you can see it. What the definition tells us is f minus f with different things plugged in over h, and that's what I've got here. I leave this blank and leave this blank, but it is basically f minus f over h. I know I'm going to put in x plus h in here and x into here, and that's my second step. And there it is. Now again, if I plug in 0 for h, I'm going to get 0 over 0, and I advise you to check that out. And so we're going to have to simplify this to make it work. And the obvious thing comes into mind is maybe we can rationalize the numerator by multiplying 1 in a special multiplying this expression by 1 in a special way. And that's what I'm going to do. I'm going to multiply the top and the bottom by the conjugate here. All right. And when I do that, what's going to happen is this is going to leave me x plus h minus x, right? This squared minus this squared. And that's going to give me a real simple numerator, maybe a more complex denominator. And here's what we have. And the numerator does get very simple. It turns into x plus h minus x, which actually leaves us h, and allows us to cancel out h in the bottom, leaving this expression here at the end. Now, it may be now that we can take the limit as h heads to 0, and when we do, what we end up with is 1 over the square root of x plus the square root of x, which is 1 over 2 times the square root of x. And that's the derivative of the